Good morning students. I hope you all are fine and safe at home. Myself Jyoti Nahar from Shiv Jyoti Educational Group, Kota, and I am going to take chapter 13, Fun with Magnets. In our last video, that is video part 1, we did about history of magnets, types of magnets, magnetic and non-magnetic substances, poles of a magnet. These topics were covered in part 1. Now in video part 2, we are going to cover up the topics, that is properties of magnet, making a magnet, attraction and repulsion between magnets, and storing magnetic properties. Coming to properties of a magnet. Now the first property of the magnet is the directional property. According to this property, the ancient people, when the magnet was discovered, ancient people, they knew that if a magnet is freely suspended, it always comes to rest in a particular direction, and that is the north-south direction. If I hang a magnet like this, it will always point in the direction that is north-south direction, and this property is used to find directions anywhere on the earth, especially by the navigators. This property is used to find the directions. Now we have a simple activity to show or to prove that a freely suspended magnet always points in the north-south direction. For this we require a bar magnet, thread, sheet of paper, magnetic needle and a wooden stand. What do? We take a wooden stand and with the help of a thread we tie a bar magnet, and when this magnet is free, we find that when it is left undisturbed, it comes to rest in the north-south direction. Again, if we twist this magnet, if we give a slight twist to this magnet, again when it comes to rest, it takes the same position, that is the north-south direction. From this activity we conclude that whenever a magnet is freely suspended, it always points in the north-south direction. Now this property that a magnet always points in the north-south direction is used in a magnetic compass. What is a compass? A compass consists of a magnetized needle pivoted at a point. It is pivoted at the center, and its north pole is generally painted red, as you can see in the picture here. The pointer which is pointing towards the north pole is painted red, and the needle, it points in the north-south direction. It is specially used by sailors, navigators. They use this to find the directions while traveling. Now an old story of China's Emperor Hong Ti tells us that he had used a magnetic statue on his chariot to find the direction when he went to new places. This chariot or this magnetic statue helped him to find directions when he was traveling or when he was going to new places. Again we have a simple interesting activity to make your own compass. For this we require a bar magnet, flat cork, white sheet of paper and a tub of water. How we are going to do this? First we take a white sheet of paper and spread it on the table. On this white sheet of paper we mark the 4 directions, that is north, south, west and east. We take a tub half filled with water, and in that we have a cork floating in it, and on that cork we place this tub on the sheet, and on that cork now a bar magnet is placed which is floating on the water. When we place this, when the cork comes to the rest, we see that the bar magnet points in the north-south direction. When it comes to rest, we see that the cork is coming to the rest in the north-south direction. Now we can adjust the paper's marking according to the position of the magnet. The magnet shows north-south direction. Accordingly, we mark the positions on the paper, and this makes your compass ready for use. Now, our next property of the magnet is attractive property. First property that we did was directional property. The second property of magnet is attractive property, and according to this property, a magnet attracts small pieces of iron and other magnetic substances towards itself. As you can see in the picture here, if a bar magnet is brought closer to a bowl having iron pins in it, you see that these iron pins fly up in the air and stick to the magnet. I will show it to you with the help of a magnet that I am having in my hand. I have some iron nails, iron pins here, and as I bring a magnet closer to it, you can see that the pins fly and cling to the magnet here. So this is the attractive property of a magnet. This shows the attractive property of the magnet. This was the second property of magnet. Now, how we can make a magnet? There are various methods by which we can make a magnet, like single touch method, double touch method, or we can make a magnet with the help of an electric current. But here we are going to discuss about single touch method. According to this single touch method, how we can make a magnet is take a magnetic substance, say an iron bar. Here we have taken an iron bar. Now take a bar magnet and put one of its poles. We are going to take only the north pole near one of edge of the substance and move it along the length of the substance till the other end. We are going to take it from here till the other end. Only the north pole will be rubbed. Now again, when we reach this end, we lift the bar magnet and bring it again closer to the first end here. We bring it down again over the first end and repeat the procedure for about 40 to 50 times. After this is done, we see that the first end of the substance, this substance acts as a magnet, and the first end becomes the north pole and the other end becomes the south pole. So this is how we have made this iron bar a magnet using this single touch method. Our next topic is attraction and repulsion between magnets. This is an important property. Like when the magnets, they pull each other. When two magnets, they are brought closer to each other, the two poles, sometimes they pull each other or sometimes they push each other. When they pull each other, they are said to be attracted to each other, and when they push each other, they are said to repel each other. Like we can say, when the like poles of two magnets, here I have two like poles, these south and south pole. When these two poles are brought closer, they repel each other, means they will push each other. Again, if I take two unlike poles, like one is south and the other one is north, if I bring these two unlike poles close to each other, they will attract. I am going to show you this property using magnets here. Here you can see that the two poles which are unlike, they are attracted. They attract each other. You can see here, they are being attracted. Again, if I change the pole, they become like poles. Means if I have like poles, they will repel. See, they are repelling each other. They are not attracting, they are repelling or pushing each other. So, these are the like poles. From here we can see like poles, they repel each other whether it is south-south or north-north. But unlike poles, they attract each other, they may be south or north and south. Now, again we have an activity here to observe the action between two like poles and unlike poles. For this we require two bar magnets and a thread and a wooden stand. What do? We take a bar magnet and hang it using a wooden stand. The other bar magnet is in our hand. When we bring the south pole of the bar magnet which is hung near to the north pole of the bar magnet in our hand, we see that these two are unlike poles as they will attract each other. The pole which is in the thread, the bar magnet which is in the thread having south pole nearer to north pole will attract each other. On the other hand, we have the north pole of the magnet and the north pole of the magnet, second magnet which is in our hand, they will repel because they are like poles. This bar magnet which is hang from a thread, it will move away, it will take the other position because they are repelling each other. So, from this activity we conclude when two like poles of two magnets, north or it may be south or south, are brought closer, they repel, they will push each other. Whereas unlike poles, it may be north or south and north, they will attract each other or they will pull each other towards themselves. Now, you must be wondering that can magnets they lose its properties? Can a magnet lose its properties? Yes, a magnet can lose its properties on hammering, heating the magnet above a certain temperature, or when we drop a magnet from a certain height. When these are done, a magnet may lose its properties. Again, magnets tend to become weaker after some time if their poles are left free. If they are left free, their poles become weak, and this is called self-demagnetization. Now, how to store magnets? When the magnets lose their properties, how can we store the magnets? To store bar magnets, they are kept in pairs. You can see in the picture, this is one bar magnet and this is the other bar magnet. And how they are kept? They are kept in pairs with their unlike poles on the same side. You can see here the unlike poles, like one bar magnet is having north pole on this side and the other bar magnet is having south pole on this side, and the two pairs are separated by a piece of wood which is kept in between, and the two pairs and iron strips which are called magnetic keepers. These two iron strips are called magnetic keepers, which are placed across the two ends of the bar magnet. So, this is how we can store the magnets. Again, magnets must be kept away from mobile phones, television, cassettes, CDs and computers. This is a way how we can store magnetic properties of a magnet. So, this was all the fun with magnets. I hope you liked it. Thank you for watching.